Example 4, a local symphony held a raffle. 2,000 tickets were sold for $5 each. There were 4 prizes, a TV valued at $1,000, a dinner value of $100, and 2 $50 gift cards. A, find the expected payback for a person who buys 1 ticket in the raffle. Okay, so we're going to need to find some probabilities here in order to find the expected value. Let's set up a probability distribution. It's going to be really important for us to find that random variable, okay? And that random variable here is the expected payback. So think about what could happen in this problem, okay? Think about the prizes that you win, okay? A TV is valued at $1,000, but remember we bought a ticket for $5. So if we think about payback, you're not actually winning $1,000. You're winning $995, or that value anyway. So let's look at our probability distribution. If we win the TV, the $1,000 TV, that payback is $995. So that's one thing that could happen here. Okay, there's 1 winning ticket out of 2,000 tickets sold, so the probability here, this is a simple probability question, is just 1 out of 2,000. And you can change that to a decimal if you want. Then we look at the dinner. The dinner is valued at $100. Now remember, we paid $5 for the ticket, so we actually are paid back $95. There's 1 winning ticket out of the 2,000 tickets sold. And then there are 2 $50 gift cards. So if you win $50 gift card, that means your payback is actually $45. And this time there are 2 winning tickets out of 2,000. Now, you should notice that you're not finished, and you can tell you're not finished because those numbers, those probability numbers, don't add up to 1. So if you think about it, there's something else that could happen in this experiment. And it's quite likely that this thing will happen in this experiment, and that's that you'll lose the raffle. You won't win any of the prizes. So think about losing the raffle. You don't get anything back. You just lost $5. So most of the people that buy a raffle ticket are going to lose $5 here, right? So if you think about it, there are 4 prizes. That means that 1,996 out of 2,000 people or tickets are going to lose. And that's your probability distribution. But that's not expected value. Expected value is that formula. Expected value is where you take 995 times this probability plus 95 times this probability plus 45 times this probability plus -5 times this probability. That's going to give us the expected value. Okay. You get a value of -4.4. The expected value is -4.4. And so think about what that means. What that means is you should expect to lose $4.40 for each ticket you bought. That's expected value. So part B, would this raffle be considered a fair game? A fair game, okay? Forget about what you think about what's fair, all right? Think about the definition of fair game. A fair game, the expected value equals 0. You've got to go back to the definition. In this problem, the expected value is not 0. So that's all it takes to say that this is not a fair game. Don't say it's not fair just because you don't feel like it's fair. Okay, it's not a fair game because the expected value doesn't equal 0. Let's say it this way. That's what makes it not fair.